Okay, for the time being, okay, all right, we have another one in. Okay, that's great. We can start. As I mentioned just now, we're going to do trigo identities. So please have your notebook ready. I don't think you can remember things I said, and I suppose you could be too lazy to go and rewatch the video, right? I mean, it's very boring. Yeah, and unless you don't mind go and rewind the video and go and replay the video that I have recorded. Okay, the file that I record could be quite big. You will not be locked out from now on. I'm using the Zoom from Jeff, so yeah, you'll be okay. You don't have to lock out. Okay, anyway, like what I mentioned, please put down the tips that I give you, practice, use the tips, and you see whether they work well for you. If they don't in any circumstances, you let me know. Okay, you let me know. Because I've been teaching for so long, those tips are helpful, especially for your trigonometry. I will share with you how I remember those formula, because for my time there's no formula list. You go into the exam hall, you only have a pen with you and your calculator. Okay, no formula list. So I have my way to remember things, as I have shared with you last week, giving you some idea how I remember the trigo identities. Even you have the formula list. I suggest you memorize them. Okay, if you know a little bit about computer, it's better to put inside your random access memory than you put inside your SSD, your hard disk. That will take you a longer time to process. Okay, access wise, if you're in your random access memory, you can get it faster and you can solve your problem in a shorter time. Okay, without further ado, I think I have opened too many files. Okay, let me open the files, and the same files that I have. Oh, I must click share, right? Where is it? Okay, share. Where is the file? Here. Yeah. You should be able to see the file I sent to you. Better still, you get them ready. I have covered ASTC, but if you still have problem, you let me know. Okay, your ASTC is super important. This is the basic of all your trigo. I have already told you last week how to understand the usage and apply ASTC, and you don't have to remember 15 identities. Save you a lot of time. 16. In fact, 16 identities, could be more. 20. In fact, the fourth quadrant is negative alpha or 360 minus alpha, if you know what I mean. If you don't know, let me know. Okay, the ASTC I mentioned last week. If you understand, you know how to use them, you can save yourself 20 trigo identities. Anybody want me to repeat the ASTC? Can you show me your hand? Do you want me to repeat the ASTC? If not, I continue my trigo identities. How? You sure you know how to do? Because you see, let me tell you something. You must pass up your homework, so I know what you don't know. If you have problem with your ASTC, I will know. If you tell me, if you send me your homework and tell me you don't know how to solve the problem, okay, then that is a feedback for me. If you don't pass up your homework, I don't know what you don't know. Sometimes I may be repeating something you already know. Then you'll be very boring for you. Okay, and sometimes I want to tell you I thought you don't know, actually you already know how to do. So please do your homework. At least you show me what you can do, what you cannot do. Right? You cannot do, you just keep, maybe you circle the question and say, oh, I can't do this. Then I will elaborate during the lesson. Okay, so all these are good for you. Only 1.5 hours with me is very short. Okay? If you pay attention to me, I give you a short break in between. You don't have to log out. Leave it as it is. And then if you bother to go and watch the video again, I will send it to you. The file can be pretty big if I don't break the file. Very inconvenient if I break the file. I got to go in, come out again, I got to log in again. Troublesome, right? Okay, now let's come back to this. I still don't know whether you want me to repeat the ASTC. Okay, now anyway, I'm going to repeat very short, 5 minutes. Okay, bear with me if you think you already know. See whether what you know is the same as what I said. Okay, what I mentioned here. Now I have a new whiteboard here to share with you. Give me a minute now. I want to make sure you really can see what I'm showing you. Okay, where's the Zoom? I must get back my Zoom. Where's my Zoom? Okay, here. All right, share. Can you see the whiteboard? Here. Okay, now you can see the whiteboard. I'm sure you can see the whiteboard. You cannot see it, better tell me. I don't want to keep checking, wasting time, right? Okay, this is a whiteboard. Now, ASTC, pay attention. 5 minutes only. I won't spend too much time here. Now, ASTC, you draw a line. You got 4 quadrants. That's your first quadrant, A. A stands for all. Everything here will be positive. Only sine positive, only tangent positive, only cosine positive. That's what it means. So the next thing what I want you to do is this. Over here, I want you to write down 180 minus alpha. Please do that, okay? Please don't just sit there and watch. Write down on your notebook. This will be super useful for you. Okay? All right, I think I better use this. The line will be straighter. Okay, now here, look at this one. 90 degree, right? This is 90 degree. And then you have a length here. Now this is your alpha. Can you see? This is your alpha. Now your alpha, please take note, your alpha is all over the place. In different quadrant, your alpha is in the second quadrant, your alpha is here. That's why your 180 minus alpha, this is the 180 minus alpha. Now this angle is talking about this angle that I'm drawing here. Pay attention so that you can see the screen, right? Cannot see, better tell me. Now this 180 minus alpha, this is the angle you are referring to. If I ask you what is sine 180 minus alpha, what do? You bring the sine down, you bring the alpha down, and it is positive. Okay, what are you going to do if it's cosine? Cosine 180 minus alpha. What you're going to get? This is another identity you should know. Bring the cosine down, bring the alpha down, just like what you did here. But put the minus in front. You do the same thing for tangent. You do the same thing for tangent because only sine is positive. Now, I have already explained, you're going to apply the same thing for the rest of the quadrant. Now, let me give you one more example, this one. Now, I'm not going to repeat the same thing on the third quadrant, but I'm repeating on the fourth quadrant. Now, you can see the fourth quadrant. Now, first thing first, you must know where your alpha is. You see, that's why I told you, your alpha in the fourth quadrant is here, right? And then when you do an angle from here to here, you either get 360 minus alpha, that's what I'm drawing here, or you draw from opposite direction, which is called minus alpha. Get it? Now, have I not told you last week? Why do you have positive, negative sign? So far, nobody tells you, right? Except me. This is positive direction, you go the other direction will be negative. So that's why you get negative alpha here. So you can address this angle either this way or that way. This way is 360 minus alpha. The other way would be minus alpha. So now I'm going to tell you the same old story for the second quadrant. What happened if I tell you cosine 360 minus alpha? You are going to tell me it is cosine alpha. If you tell me cosine minus alpha, I also tell you it's going to be cosine alpha. Understand? This is the identity. If I'm going to sine the 360 minus alpha, what will you get? You bring the sine down, you bring the alpha down, and you put minus in front. Why? Because in the fourth quadrant, whose territory in the fourth quadrant is cosine, isn't it? Look here, look here. This is a fourth quadrant. You know the angle fallen into fourth quadrant is either 360 minus alpha or you call it minus alpha. So what happened when you sine this angle? When you sine this angle, you get minus sine alpha. Or you sine minus alpha, what will you get? You will get minus sine alpha. So do you know how to use ASTC now? What happens if I tell you tangent? It's also going to be negative because in the fourth quadrant, only cosine positive. You're going to pull down the tangent. You're going to pull down the alpha and you put a negative in front because in the fourth quadrant is cosine, not tangent. So first thing first, you examine what is the angle you are tangenting. What's the angle you are sining? You sine 360 minus alpha. So you better make it negative sine alpha. How you get that? Pull down the sine, pull down the alpha, and put a negative in front. So have I not saved you altogether 20 trigo identities? Get it? Now you're going to use this for your JC also. If you want to go poly, continue your maths, you're going to do the same thing. All right, so you can't run away. You better learn now. It's all for your own good. Okay, you definitely benefit from this. Once you understand how to make use of ASTC, you can do a lot more. You can do a lot more things. Okay, but basically, you know how to tackle when someone tell you what is tangent 360 minus alpha. You will tell me minus tangent alpha. Okay, reason given, because it's in the cosine quadrant, the tangent is going to be negative. How do you get tangent alpha? Pull down the tangent, pull down the alpha. That's how you get it. Okay, that's it for your ASTC. All right. How do you make use of ASTC to solve trigo equation? You're going to do the same thing here. You must firstly know what is the basic angle. Then after that, you must know fallen into which quadrant. And then you know how many rounds you're going to repeat. Of course, the range, the valid range will be given by the question. I have already gone through that last week. Okay? Cannot. Okay, any question with regards to ASTC? But no problem. If you still have problem, you can stay back. I can explain to you again. Okay? Or I think the best thing is what? The best thing is you go and do the question now, please. You do the question, you solve one trigo equation, you list down all the possible answer for me. Then I will know whether you can understand this ASTC well or not. Okay, that's the best thing. All right, cannot. All right, then no problem. I'm going to proceed with the next. I hope I'm not going too fast. Someone complain I'm doing too fast. Okay, all right. Can? So far okay? No problem. If I'm too fast, you better tell me. Okay, that's your ASTC. Let us go back. Can you see? You can see I've changed the screen now. Now, this one I suggest I received some solution. Okay, I received some answer from you from last week. So please draw the right angle triangle. Okay, first thing first, do you know how to draw the right angle triangle? Because they already told you alpha is an acute angle, right? So must be first quadrant. First quadrant, you draw on the first quadrant. Yes or no? Cannot. Can you see the screen I'm sharing? Make sure you can. Cannot, you just voice out. Because what I can see, I suppose you can see. Okay. Okay, this you can use the ASTC to find out all the angles you want. Look at the example. See whether you understand this. Okay. Now this is also about your ASTC. You don't have to state Pythagoras theorem. You write down the 4, you write down the 5, and then you write down the 8, then automatically you'll get the answer. Okay, in your working. Okay, another thing that I have shared with you, what is that? Is the special angle, right? So please make sure you know this special angle. And can you write it down again, please? One more time. Beside this table, I would like you to draw this special angle. Can you see the red line I'm drawing here? Draw this longer. The vertical line is shorter. So can you please write this down? Every time when you get the answer booklet, write this down. 1, 2, square root 3. follow Pythagoras theorem, you won't go wrong. And this is your 30 degrees. Of course, when this 30, this must be 60 lah. Add to add to 180, right? Because it's 90. Yes or no? Special angle. So do you know how to read this? You know how to read this? Of course, your 30 degrees is pi over 6. Your 60 degrees is pi over 3. This one you must know lah. This is your E-maths, right? In radian. Now, how come your sine 30 degree is half? Look at your sine 30. Isn't it opposite? Opposite is 1. Hypotenuse is 2. That's how you get half. That's how you get half. So the whole table, you can just refer to this triangle. You don't have to memorize the table. And you have to know the table, okay? Because don't just rely on your calculator. Because if you press calculator, square root 3 will be irrational number. You have a lot of decimal places, a lot of decimal, no ending, no pattern. That is irrational number. They want you to answer exact. That means they want you to show square root 3 over 2. They want you to show exact. Square root 3 is exact. If not, then you will have irrational number, a lot of decimal places as your answer. Okay, that's not acceptable. For some of the question. So for this one, can you mark here and put 45 degrees? Please put 45 degrees. You know, when you divide pi by 4, you draw a line. This is either 180, or you can call this pi. You split it into 4 parts. Don't you think it's 45 degree in this case? Then it's 1 square root 2. Okay, so please, I repeat many times, these two triangles, memorize it in the exam. When you take the answer booklet, straight away write this down. For sure, you need to refer. Okay, put down in your answer booklet. So you'll get all this. You'll get all this. Whether you sine, cosine, tangent, you just go according to this triangle, you'll get the answer. Okay, now. But of course, if you want to press calculator, you can. For 90 degree, for 0, for 0, for 360, for 90, all these, you remember the graph lah, because after all, you're going to go through the graph, isn't it? Your trigo graph. Yes or no? For your sine graph, what happened? For sine graph, the best thing to remember, your 90 degree is referred to your sine graph. Your sine graph is like what? What did I say? It's like your hand go up to the ceiling, correct? And then come back to your hand, drop onto the floor, and go back to your hand. Can you see the ball bouncing? Go up to the ceiling, come down to your hand, drop onto the floor, and come back to your hand. Okay, that's how you remember your sine graph. Any problem here? That's how you remember your sine graph. And then you remember, you always divide your sine graph into 4 equal intervals. And then you get 90, 180, 270, and 360. Now, all these angles, you will have it here. Can you see all these special angles? They are here. Then you can just refer, 90 degrees is 1, right? And you do a few more. You make a conscious effort. You do a few times, you will know sine 90 equal to 1. No need to refer to the graph. You also know sine 90 is 1. Cosine 90 is 0. All these you will know. What I want you to do is to make a conscious effort. Conscious effort. Okay, be observant. Have the awareness. Put in some effort. Tell yourself you can remember. You will remember. Okay. All right. Okay. So cosine, I must well go through the graph. Start from where? Cosine start from where? Cosine start from 1. All right. It's the same like sine, but it's half shift. You say phase shift. Phase shift. You shift 90 degrees, you'll get sine. Okay. You start from here. You see, if you shift to the left 90 degrees, you get cosine graph. You get what I mean? Instead of 90 degrees, you got 0 here. So it's on the ceiling. You start from the ceiling. Then what happened to the ball? Drop onto your hand. Before you drop onto the floor, come back to your hand and go back up to the ceiling. So it looks like a bird, right? You can see like that. It looks like a bird. All right? How do you draw a bird like that? Okay, it looks like a bird. So 0, 90, 180, you divide into 4 equal intervals, and then you will get all these points. All these special angle will take care of this. That is your sine and cosine graph. So this table you can remember already by now. Okay, this table can be gotten from the two right angle triangle. One is an isosceles triangle. These two triangle, by the way, is your set square. Your mathematical instrument, you have a set square. You know what I'm talking about, right? You normally don't bring, please have the set square with you. You learn how to draw parallel lines, and then you get these two triangle in your set square, and you can always refer to 1, 2 square root 3 and 1, 1 square root 2. Then you get all the trigo ratio for your sine, cosine, tangent. Am I going too fast? If not, then someone complain and go too fast. You just follow this. Follow this. You see, I think your teacher must have gone through this with you. It's just that your teacher may not mention like what I tell you. You refer to the two triangle, then you don't have to memorize this. Okay, these are special angle. You need them. You need them when you do your question. Okay, so that's it. I'm going to move this down. Any question? So quiet tonight. How? Zihao, cannot? Zihao?
Yeah, okay.
Don't fall asleep, please. I will remind you. Okay, here. I will wake you up. Okay, come. Let's move on. Okay, example 4. Now, example 4, like what I said, please. This is your ASTC. I want you to get full mark. Okay, you must be able to list down all the angles. I don't want to repeat this. I already done last week. So look at the range. So get the range. Okay, they tell you 0 to 360, isn't it? They tell you the range is 0 to 360. So you make sure within this range, you create a new range. Then you will know where to stop. You keep adding 360. All right. But if you still have problem, you let me know. You can stay back for 5-10 minutes. I can clarify this example. The best thing is just to do the question, see whether you get see whether you can get all the answer correct. Don't miss out any. Don't give extra. All your answer must be within the range they tell you. You must create a new range. They tell you 0 to 360 is the angle X, is the angle Y, but they want you to find this correct. So you must go according to what I told you last week. Okay. So, okay, that's it for this. You must multiply 3, divide by 2, then add 15 throughout within the range. Cannot. Or you want me to tell you again? Cannot. This one okay.
Yeah, can.
Can. Okay, good. Yes, you see, I can hear some response then. The other two, don't be too quiet. If not, then I will always answer to Zihao's question. Then you will feel very lonely. You'll be left alone. Okay, don't, please. We all on the same boat. Don't be shy. Right? Now, I'm not going to go through trigo graph because drawing very troublesome. Maybe I will. Okay. One of these days, maybe next week or so. Okay, I want to move on to trigo identities. This one I will go through. Okay, I promise you. If you still have problem, let me know. 5 period, amplitude, all this. Right, today I want to cover trigo identities. So please write down. Hello, I already told you, get your notebook ready. If you have different color, put different color, okay? Red blue black okay, different color, green okay? Now, so your notebook will look more interesting. Okay. All right, take a look at this. I want it to be thicker. Okay, I teach you how to remember this trigo identity. The first most important trigo identity is this. Okay, one of the most important. You already know, right? I mentioned to you last week. How you remember? You remember tangent is sine over cosine. Of course, you must put the angle in. The one I no need to mention. So you remember in your mind, tangent is sine over cosine. Cotangent is cosine over sine. Reciprocal, flip your numerator and denominator. Okay, now I teach you how to do this graph, how to make use of this. Now, your sine square plus cosine square, you notice I never mentioned the angle. You cannot sine or cosine nothing, right? So this is your trigo identity. Sine, cosine equal to 1. Can you put an arrow here? Sine square plus cosine square equal to 1. That's how you make use of this diagram. The next trigo identity is 1 plus tangent square equal to secant square. Now, how do you make use of this? You go this way. 1 plus tangent square equal to secant square. Can you see? 1 plus tangent square equal to secant square. Now, you just put a core in front of the tangent. What would it become? If you put a core in front of tangent, what would it become? It become cotangent, right? You understand what I'm saying? So you put a core in front of tangent, you put a core in front of the secant. So what happens when you put a core in front of secant? It will become cosecant, right? Now, now these two are not so important. The most important is this one. Okay. Now your trigo identity. So you want to prove trigo identity. What is your first rule of thumb? First thing, if you're not familiar with these two formula, even you have the formula list, you are not familiar, change everything to sine and cosine. Can you write that down? Change everything to sine and cosine. What is everything? Tangent, you change to sine over cosine. Cotangent, you change to cosine over sine. Then what is another thing that you need to change to sine and cosine? Secant, you change to 1 over cosine. Look at the third alphabet, right? I told you last week. Cosecant, when you see cosecant, what you do? You change to 1 over sine. Understand? So you have successfully changed everything else. Everything else. What do you mean by everything else? Everything else except your sine and cosine. Sine and cosine are already there, right? So no need to change. Correct. So the rest, you have tangent, you have cotangent, you have secant, you have cosecant. Now change the other 4 trigo identity, change them to sine and cosine. You get it or not? Altogether, you have 6 trigo ratio. Yes or no? Besides sine and cosine, what you have? Besides sine and cosine, what you have tangent. You change it to sine over cosine. You have cotangent. You change it to cosine over sine. You have secant. Look at the third alphabet. You change it to 1 over cosine. When you have cosecant, you look at the third alphabet. You change it to 1 over sine. Now, that is your first step. You want to do trigo identity. If you are not familiar with these two, you change everything to sine and cosine, and you use this identity, sine square plus cosine square equal to 1. That's it. Full stop. You just have to know that. And your trigo identity will have no problem. Of course, beside this, you have double angle and so on. The one, when it comes to double angle, then I tell you. Okay? In the meantime, if you need to prove trigo identity, change everything else besides sine and cosine, change the rest of the 4 trigo identity, change everything to sine and cosine, then you use this formula. I can say 80% you will have no problem proving identities. Okay, do you get that or not? Have you written down? Please write down. Please write down. Okay, now I'm going to move on and give you an example and show you what I mean. Okay, all these I already mentioned just now. Now you want to prove your left-hand side equal to right-hand side. Please take a look at the example 1. What happened? They look at example 1. I want to enlarge it a bit. They look at example 1. Now, the first thing you want to ask yourself is, should you go from the left to the right or right to the left? Now, the left already have all the sine and cosine. Can you see? You already have all that. So what did I tell you? You change tangent to cos. You take cotangent, change to cosine over sine. You take tangent, change to sine over cosine. Isn't this what I told you just now? Look at the arrow here. You change tangent to sine over cosine. You change cotangent to cosine over sine. Then you change secant to 1 over cosine. This is what I mean just now. Okay, so you prove from the right to the left. Why? Because you can do something about it, right? From the left to the right is very difficult to do, right? But from the right to the left, you follow what I have told you. My tip is to change sine, cosine, change tangent, cotangent, secant, change all this to sine, cosine. At least you know what to do next. Okay, you have something to do. Now, come on. You have been doing algebra, right? You have been doing algebra. Don't tell me you don't know how to merge the fraction. Every time when you get a fraction, what you do? Of course, you take common denominator. Every time you give you A over B plus C over D plus minus E over F, what you do? You take common denominator. You get A D F plus B plus C CBF minus EBD. Then common denominator is BDF, isn't it? So this is a standard step, right now. You merge them. You merge the fraction. That no need to tell you. So for trigo is the same. What to do with the next step? After you have changed to sine and cosine, what are you going to do with the next step? You merge them. After you merge them, isn't it what I told you just now? What did I tell you? The most important trigo identity is sine square plus cosine square equal to 1. And that's it, finish. That's how you get your left-hand side. And you're done. Normally, it shouldn't be more than 4 steps. Unless you're very long-winded, but you have some shortcut. Even 3 steps, you can get the answer. So what did I tell you again? Change all the tangent, cotangent, secant, cosecant, change everything to sine and cosine. When you see fraction, you add them up, take common denominator, and you will get the answer. And then use this most important trigo identity, which I mentioned to you just now. This one. What is the most important trigo identity? Sine square plus cosine square equal to 1. That's it. I don't think you can forget this. If you forget this, that means you're not doing trigo at all. Okay, if you pay attention to me, at least you cannot say that you don't know this, Nobody would say that they don't know this. They don't know sine square plus cosine square equal to 1. This is ridiculous. If you go through trigo lesson, you say you don't know this identity, that means you're really sleeping. Okay, can sine square plus cosine square equal to 1. That's it. Now take a look at the second example. See really what I said. Now look. You can go from the left to the right, or you can go from right to the left. Your teacher ever taught you, right? If you see more items, it's easier that you go from more item to the fewer item. So what you do here, take common denominator again. Isn't it the same? You can see. You take common denominator. What you get? You get 1 minus cosine. Don't forget, when I said sine square plus cosine square equal to 1. This is also the same identity. Okay, please. You cannot tell me this is a new identity. No, it's from the same identity. Can you see? Can you see it's from the same identity? Now, if I tell you sine squared plus cosine squared equal to 1, it's the same identity. When you see 1 minus cosine, isn't it sine squared? I just bring this to the right side, isn't it? So do I get this? It's the same identity. You cannot count this as 3 identities. It's only 1. It's still sine square plus cosine square equal to 1. You move this over, you'll get this. Correct. That's how you get this. And then you'll get the answer already. Finish. Now it's very difficult for you to go this way back. Difficult, right? Because you're adding, you want to expand, it's very hard. Okay, you try going backward and see. This one you can go backward, this one no problem. But from here to here is a little bit of problem because your sine squared. You must get this. Okay, this is one of the technique. Now pay attention, pay attention. Doesn't mean that you can't do that. You walk backward also can. You can see. When you walk backward, you will be able to see. Look here. Look here. Look here. Pay attention. Look here. Now, when you get sine square, what you do? You get 1. Don't write 1. Write 1 squared over cosine squared. Cannot. It's just like your a squared minus b squared. Then that's how you get 1 plus cosine, 1 minus cosine, isn't it? Correct. Isn't it your identity for algebra? You know what I'm talking about. A squared minus b squared is a plus b, a minus b, right? Yes or no? A plus b, a minus b. Yes or no? Can you see no? So this is what I'm saying. When you see sine squared, you change to 1 squared minus cosine squared. Don't write 1 now, Don't write 1 minus cosine squared. Write 1 squared minus cosine squared. Then you get a plus b, a minus b. That's how you got these two coming up. All right? And you split them. Of course, it's more difficult. I still encourage you to do this way. Don't go the other way. Okay? Now, how do you decide which way to go? Look for more items. Look for more items. If not, you get stuck. Okay, if you get stuck, what will you do? Let's say I don't know. I don't know I need to go from the left to the right. I try to go from right to the left, and then I get stuck. Now, this is what I'm going to tell you. Now, if I say I'm going to meet up with you, okay, I want to play table tennis with you, or I want to meet up with you, I want to see you. So instead of me going all the way to your place, we can meet somewhere in between. Save time, right? Correct now. I say meet me at Bishan. So isn't it easier? I go from my house to Bishan, and then you also go from your house to Bishan. Then rather than I go all the way to your house, isn't it? Correct now. So this one is also the same. If you think that you go this way, it's very hard to reach what you want, you try to go both ways. You get what I mean? You get what I mean? So I can get the first two lines I do here, and then the last line I do until here. I get the same thing. That's okay. You have proven. You have proved the identity as well. I mean, should you not know which one to go? It doesn't matter, isn't it? Of course, it's good to find more items because combining something is easier than you expand. Because when you expand, you got a lot of possibility. You know? Correct. Okay. Any question here? I'm going to give you more examples. In fact, all these I have given to you already in the notes. So I expect you all at least read it up. Huh? If not, then you refer to your book example. Look at this one. Look at this one. Example 3. Can see? Example 3. Now, if you have problem like what I said just now, you have to do a bit longer. Huh? If you change everything to sine and cosine, you do a bit longer because power 4. Correct? You will expand it, then you have to do a bit longer. But this one, because they show you as an example, they want to tell you, in fact, you still need these two identity. What is the other two? 1 plus tangent square equal to secant square. How do you know you need this? 1 plus cotangent square equal to cosecant square. You put a co in front. How do you know you need this? Because the question has this, right? No? Correct? No? The question has got secant square. When you see something like that, what you do? If I tell you x squared minus y squared, what will you do? Or maybe not y squared, sorry, it's x squared. So x to the power 4 minus x to the power 2. What you do? You factorize. You take out the common factor, isn't it? Isn't it what you're going to do? Yes or no? So isn't this the same? Correct. Can I let my x be secant x? Secant theta. Correct. You know what I'm talking about. When you see secant to the power 4 and then secant to the power 2, isn't it the same like x to the power 4 minus x to the power 2? What you do? You tell me what you do. You factorize out the common factor. That's what you do, right? So you do the same thing for trigo identities. And then you know your secant square minus 1. Look here. Look here. You bring the 1 to the right side. Isn't it your tangent square? Is your secant square minus 1? Yes or no? Correct or not? Then you just change it to tangent square. Finish. Then what is your secant? Secant is 1 plus tangent squared. And that's how you get your tangent now. So you know what you are expecting to get, right? You want the result to be tangent, isn't it? How are you going to change from secant to tangent? There's only one identity here. You can see how they are related. Can you see? Can you see they are related by tangent and secant? They are related. Can you see or not? Related by what? Related by this identity given to you. So you look at the question. You get secant here. You got tangent here. Of course, you need to use this. Of course, you need to use this identity lah. If not, what else you do? You get what I mean? Now, as homework, you can try using sine and cosine. As homework, can you do? Okay, I assign this as homework. Can you write this down? Now, you already have this in your notes. In your WhatsApp, you open up. So what I would like you to do, don't do it this way. Let's say you don't do it this way. Let's say you don't know. For example, you don't know how to change it to, don't know how to use this identity. Let's say, for example, you never thought of using this identity. So what was my advice just now? I say change everything to sine and cosine. Secant, what you do? You put 1 over cosine 4. Is it okay? Third alphabet. And then minus 1 over cosine squared. You can do like that. And then what will you do? You factorize out. You factorize out the cosine squared. And then what you get? You get 1 over cosine squared theta minus 1. Supposed to be your homework. Okay, I have done most of them for you already. So 1 minus cosine squared theta over cosine squared theta. Now this one is still the same. Nothing go missing. It's still there, no? Still there. Don't miss out. Okay, must write everything. So 1 minus cosine squared is sine squared, isn't it? Correct? Isn't it sine squared? Sine squared over cosine squared, isn't it tangent square? Correct? Now you're almost there already. And what is this? This one, isn't it your secant square? Sorry, cosecant square. Your cosecant squared, and then isn't it, secant square, then isn't it 1 plus tangent square is secant square? That's all. Correct? 1 over cosine squared, isn't it your secant square? What is secant squared? Secant squared is 1 plus tangent squared. Go backward. Here, go backward. Didn't I tell you last week? I say maths got only 2 types of question, right? I'm going to repeat every lesson. Either you go forward or you go backward. Understand? Either you find out what is 1 plus 2, or you find out what must you add to 1 so that you can get 3. So you just go forward, backward. Your formula, you don't remember 1 plus tangent square. You also know that secant square is 1 plus tangent square. You must go backward as well. So how do you know which way to go? Depending what the question give you lah. Have I not answered your question? If they give you this way, then you go this way. If they give you tangent, then go the other way. What is the logic behind? They can't give you a question that you don't do anything, right? So they always give you a question that you need to do something. So when they give you this, you do that. When they give you that, you do this. Because you only have 2 ways, right? Either forward or backward. See again, this is what I mean. Look here. If you see secant squared, you're going to change to 1 plus tangent. If you see tangent, then you're going to change to secant squared minus 1. This is what I mean. If you are given this, then do that. You are given that, then do this. Don't tell me they give you a question, you don't need to do anything, right? So when they give you something, they expect you to do something. Because you either go forward or you go backward. If they give you back, then you go backward. If they give you forward, go forward. That's what I mean. Okay, let me show you one more example to tell you what I mean by that. Now you remember your log. Do you remember your log xy equal to log x plus log y, right? Very simple. My student asked me, how do I know I need to go from here or there? My answer is very simple. If you see this, then you do this. If you see that, you do this. Correct. Either this or that. If you see that, do this. If you see this, do that. That means if you see LGXY, what you do? You put LG plus LY. Don't tell me you don't need to do anything here. If you see LGX plus LGY, what you do? You merge them. You put it as LGXY. This is what I mean. You either go from the left to the right or you go from right to the left.
Yeah, I get you.
Yeah. Okay. I know. I'm repeating already. Okay, never mind. Since you get it, I hope the other two can get it also lah. Huh? You see the left, you do the right. You see the right, you do the left. So you definitely need to do something. So there's a very simple logic. Definitely you can do. Okay, now I have already been talking for so long. So please let us do something together so you won't fall asleep. Okay, come, let's do something. The next example, I see whether I can see something here. Okay, one more identity. Okay, I don't, this one is showed already. This is a trigo equation. Compound formula. Okay, compound formula, compound angle. Compound angle, in fact, I have already mentioned when we're doing R formula, yes or no? When we're doing R formula. How did I ask you, how did I tell you to remember this? How to remember this? What did I tell you to remember? I say you don't mention the AB.
Sine, cos, cosine.
Very good. This is the Cojia. Please remember the. Then when you see cosine, what you do? Cos, sine, right? Then after that, then you fill in the AB. You fill in later. You understand what I mean? Okay, I changed the color here. Now you see, okay, when you see plus minus, there is plus minus. When for cosine, you see plus minus, you put minus plus. That means there is plus, you put minus. When minus, you put plus. For tangent, how to remember tangent? I never tell you about tangent, right? So this is how I share with you how I remember tangent. As if you are multiplying in. But they say as if. What happens if I say as if? As if means not really lah. As if it disappeared. Then. So as if you are multiplying in. So when you multiplying, what you get? You get these two, right? Then from these two you refer. From these two you refer. You know. Let's say I tell you how to remember A plus B. Why disappeared? What I write disappeared. Hold on. I think okay. Tangent A plus B. So how you remember if you don't have a formula list? You remember it as if you're multiplying as if. But of course, it is not lah. So you know there's some more thing to fill in. So the bottom one, you see plus, you put minus. Correct? And then you put 1 minus. Now this is a sum, right? You write it as a product. Tangent A, tangent B. Now that's how I remember. Now if I have tangent A minus B, so what you do? As if you are multiplying in. So when you multiply in, what you get? You get tangent A minus tangent B, right? That's what you get. But this is only as if. It's not really like that, right? So I still need to write some more because I know only the top part as if I'm multiplying in. But the bottom part, you see minus, you put plus. And then you see this as subtraction, you just put it as a product again. Now that's how you get the trigo identity here. You see plus, you put minus, you put minus, you put plus. It's the same thing here. So I hope you understand the compound angle. Now, once we know the compound angle, pay attention here. I'm going to tell you how you remember the double angle formula. This one you must write down. This one. At least you can explain to yourself, or there is an explanation. Not so boring that, I just told you the formula, just memorize it by heart. I want you to let the B become A. Then you tell me what happened. I want you to let the B become A. Then what happened? I will get the sine 2A. That's my double angle formula, isn't it? A plus A is 2A ma. Why? Because I'm telling you, instead of sine A plus B, I'm going to let the B become A. So what will you get? You'll get sine A plus A, right? Yes or no? What is A plus A? 2A lo. Correct? No? So that's your double angle formula. Now, since your left-hand side, you have changed the B to A, then all the B must change to A. Well, not fair, right? Because it's in the whole equation. If you change the left-hand side, if you change the B to become A on the left-hand side, you do the same for the right-hand side. So what will you get? Tell me what you get. Sine A, will you get cosine B? No. You get cosine A because I have changed the B to A, right? And then you add, what happened? Cosine A, sine B? No, I changed the B to A. So what have you noticed? 3 times 4, 4 times 3, the same, right? So isn't it 2 sine A cosine A? That's how the double angle come from. The double angle come from where? Come from letting B equal to A. Understand? Now, I don't have to explain the rest because it's going to be the same. Can see? Now, why don't you do it yourself? Come. Or let's do together. I'm sure you have a pen and your pencil, your notebook with you, right? Come, let's do together how you get cosine. Now, cosine is more tricky because sine only have one way to do. Your sine 2A only have one formula for sine 2A. Your sine 2A is 2 sine A cosine A. There's only one. But cosine 2A have 3 in 1, you know. You have 3 in 1 coffee, 3 in 1 shampoo. Okay, your cosine has 3 in 1. Have 3 different outcomes. Why? See, do the same. Please do the same. Do together with me, please. Do together with me. So what I get? You get cosine 2A. What you get? You get cosine square A. Why cosine square A? Because your B become A, right? Cosine A times cosine A, isn't it cosine square A? Minus sine square A. Why? Because your B become A, then you got sine A times sine A. Isn't it sine square A? By the way, sine square A is actually sine A bracket the whole thing squared. Okay, it's just that the square put inside lah, huh? Cannot. Why do I say that you have three trigo identity? I have one here. Remember what I told you about the most important formula? Now I want you to change the cosine to become sine. You get 1 minus sine squared. Can you see? 1 minus sine squared. So what you get? What you get? You get 1 minus 2 sine squared. That is the second formula for cosine. Can you see? Now this is the hybrid. You know what's hybrid? No? Hybrid. Like the car hybrid. You put petrol also at the same time. You can use electricity. You use your battery. Hybrid. Now this hybrid consists of sine and cosine. This hybrid. Sine and cosine. This one, sine alone. Can you write down? Sine alone. Only sine. You don't see cosine. But I can also have cosine alone. I don't want sine. I only want cosine. Cannot? Can. Look, what happened to your cosine 2a? Your cosine 2a is cosine square a minus sine square a. So just now, what did I do? I changed the cosine square a to become 1 minus sine square a. Now what do? Remember to put bracket. Bracket. I changed the sine square a to become 1 minus cosine square a. Now that's how I get the third formula, which is 2 cosine square a minus 1. So that's why I said cosine 2a come in 3 form, 3 in 1. So again, what is cosine 2a? Cosine 2a can be cosine square a minus sine square a. Can you see now? This is hybrid. Cosine 2a can be 1 minus 2 sine square a. Yeah. Cosine 2a can be 2 cosine square a minus 1. Can you see or not? How you remember this? Let's say you don't have a formula list. Can you see the pattern? When you see cosine, cosine come first. Right now, you see cosine come first. The sine can come, but come later because it's cosine 2a. Look at your sine 2a. Your sine 2a, you will write it as 2 sine a cosine a. Okay? You see cosine, you see sine, sine come first. Of course, you can write 2 cosine a sine a, but I would like to consistently follow the same rules that I used to remember. How do I remember cosine 2a? I remember cosine 2a by changing b equal to a. When I change b equal to a, I know I can get cosine 2a. Yes or no? A plus a is 2a ma. Correct now? Then I change b to a, then I get cosine square a. Then change b to a again, then I get sine square a, isn't it? You see? I want to erase this. No, I can't. So I want to erase this, I put a. So isn't it sine square a? So your first formula is easy. Your first formula is hybrid. You get cosine square, you get sine square, but seldom use the first one. Mostly you use the second or the third one. You know why? Do you know why you use the second and the third one? Because the question always asks you either sine or cosine. They hardly ask you cosine square minus sine square. You only see cosine squared minus sine squared if they want you to find out what is cosine plus sine, what is cosine minus sine. Because this is again your identity, right? So what happens if you have cosine square a minus sine square a? What will you do the next step? You say cosine a plus sine a. Then what will you do? Cosine a minus sine a. Can you see? Now, isn't this what you have been doing? A minus b, a plus b, or a plus b, a minus b. That's why you get the a square minus b square here. Now, that's how you make use of the double angle formula. If you need to use cosine square a minus square sine square a, the next step is a plus b, a minus b. That's why you need to use this. If not, you seldom use this. Huh? Through experience, I mean, if you do a lot more, you think back what you have been doing, then you will realize that this is the pattern the question like to ask you. Okay? Cannot. Okay, any question? So far, I have covered compound angle. And please write down, please. At least you must write down let B equal to A and how you can generate the double angle formula by letting B equal to A. Okay, I don't know whether your teacher is going to teach you this way, but I'm telling you this so that you can relate better, so you understand how you can get the double angle by letting B equal to A. It make more sense, right? I don't know. To me, it make a lot more sense, and I can relate them. Even I don't have a formula list, I can get them out. I just have to know sine square plus cosine square equal to 1. Of course, from there, I also know cosine square is 1 minus sine square, and then sine square is 1 minus cosine square. It's all about the same. It's the same formula I'm telling you. Same identity, sine square minus cosine square right now. So tangent is the same thing. I don't have to tell you. And you will know what is your tangent 2A. The tangent 2A is 2 tangent A, because your B has become A, right? So tangent A plus tangent A become 2 tangent A. Then this one become 1 minus tangent square A, because it's tangent A times tangent A. That's it. That is your double angle formula. Okay, so far, okay or not, this one? Is that okay? Hey, the other two so quiet, eh? Cannot.
Yeah, can.
Can, okay, all right. Now, one more thing before we go for a break. Now, don't always think that double angle formula must be sine 2A equal to 2 sine A cosine A. Don't think like that, okay, please. I want you to see the ratio. What do you see here? 2A, right? What do you see here? A, right? So the ratio is 2 to 1. So what happens if I ask you sine 4A? You say, oh, I never learned that. I learned double angle formula. I never learned sine 4A. But actually it's sine what? Sine 2A cosine 2A. What? Ratio what? Do you know or not? Do you realize? You spend your 6 years in primary school, you only do ratio. Everything is ratio. Percentage is ratio. Fraction is ratio. Almost 80% of what you did in modern method is about ratio. So this is a ratio, isn't it? Isn't it 2 to 1 also? So if I ask you what is sine A, don't tell me you don't know what is sine A. What is sine A? Sine half A, cosine half A. Ratio what? 2 to 1. If I see A, then this is half. When you see 4, then you get 2. What happens is sine 3A. Then 2 sine 3A over 2. Then cosine 3A over 2. Okay, same. Same. They are all double angle formula. That's why they say double. Must it be 2 to 1 then double? 4 to 2 also double. 1 to half is also double, right? So that's why they say double angle. Yeah. Okay, understand? So please be flexible. Anything you change, all right? You know what Bruce Lee say or not? Bruce Lee, Lee Xiaolong. I know everybody know Bruce Lee. Right? They say you must be like water. When you put in a teapot, it becomes a teapot, right? So you must be flexible, okay? So don't only think double angle formula is sine 2A, then you get sine A, 2 sine A cosine A. You can have sine 4A, then 4 will become 2, correct? So I have to be flexible. In Chinese, they say 举一反三, right? 举一反三. Okay, I think it's good time we have a short break here. It's already 1 hour I've been talking. So please refer back to the notes. In the meantime, during the break, I'm still here. You can have your break, go and have a drink or something, and then we continue. And I show you more example about how you prove trigo formula, trigo identity. And you have to do a lot, really, really. You cannot just survive by doing a few questions. Cannot. You will not be familiar enough and you cannot finish in time. Trigo identity is one of the easiest questions to score. You definitely, because you know the answer. You know whether you do it correctly or not. You won't make careless mistake. Because if you can't get the answer, you know you can't. If you can get, then you should get full mark. Okay, very unlikely you don't get the mark if you know how to do. Yeah. So we'll continue with trigo identities. I give you some more example during the break, and then all the trigo identity then R formula. Then almost except the graph, I've covered most of them already. No wonder, actually I'm quite fast. Okay, but please You must do your homework lah, huh? You must do. Then I can see your presentation. Or follow the example. Your presentation, please follow the example. You got so many examples. Not only what I give you here. Your textbook, your notes, whatever your teacher had given you. Then all the questions you have done for your homework, you see the solution. Check your answers and see whether you have written properly or not. Okay, okay. Let's have a 5 minutes break. Okay. Let's have a 5 minutes break. Any question? Any question? No? Am I going too fast?
No. No.
Cannot.
Can.
Okay. You'll go for your break, huh? 5 minutes time. I'll see you back here. Okay, let's start again. Now, I don't want to continue here. I actually send you this, right? Hold on. Okay, let's do something simple. File sharing has stopped. Okay, file sharing has stopped. I must share the file. Where is it? Here. Yeah. Okay, can see? Can see? Okay, let's start something easy. Have I not done this? Look so familiar. Okay, come, let's do together. Come. Can see, Can see what I'm sharing here? Okay, Cannot see, better tell me. Now, what did I tell you just now? When you see two fractions, what you do? You take common denominator, right? I'm sure you know how to take common denominator. You multiply what you don't have. You don't have sine, right? You look at 1 minus cosine. You don't have sine theta. You multiply sine theta. You multiply sine theta. Yes or no? Then you take common denominator. And then you get sine squared minus 1, right? Sine squared minus 1 minus cosine theta bracket the whole thing. And then 1 minus cosine theta and then sine theta. Do you have any problem taking common denominator? It's the same thing that you do for algebra, right? You multiply sine theta, for this. You look at the denominator, this is what you don't have, right? What you don't have here? You don't have 1 minus cosine theta, right? So you multiply 1 minus cosine theta. Numerator and denominator, you do the same. And then you merge them. When you merge them, you will have the denominator here, which is the product of the two denominator here. Correct? And then you get sine square. And then what did I tell you? Can you remember? I give you the tips, right? I said sine square theta plus cosine theta equal to 1, isn't it? Correct? No? So when you multiply this inside, what you get? When you multiply this inside, what you get? You get sine square theta minus 1 plus cosine square theta, right? How come get 0? Wait. Oh no, there's no square here. There's no square here. Sorry. There's no square here. Come, you do together with me. You do together with me. There's no square. So you get sine square theta. Still cannot write properly. Sine square theta minus 1 plus cosine theta. Right? Yes. And then the bottom one is 1 minus cosine theta. And then you got sine theta. Now, like what I told you, instead of me meeting you all the way, I got to travel and meet you somewhere halfway. So if you get stuck here, you can go from the right to the left. So you can move backward, right? So what is your cotangent? Your cotangent is actually cosine over sine, yes or no? This one you know, right? So you want to cut shorter. As long as you want to go from one way to the other way, you can always go this way, right? Correct. So you know the end result must be cosine theta over sine theta. That's how you get your cotangent theta on your right hand side, yes or no? So because of that, you know you need to cancel off this. Can you see this? Okay, I stop here for a while. If you cannot get it, you better tell me. Oh, please tell me, don't be shy. You understand the answer is cotangent theta, right? Here, right hand side, yes? But because let's say I get stuck here, I will know I move one step back. If I move one step back, isn't it cosine theta over sine theta? So you already see the sine theta, right? You already see the sine theta. Can you see the sine theta? After I have taken common denominator, I have a sine theta here. Then I have this extra here. Can you see or not? Here. I have this extra. If I cancel this, then I get sine theta alone. You see, I need to cancel this. So that's the reason why I'm able to think of the next step. Where's my next step? This is my next step. So what did I tell you? You are using the identity of sine squared. You're using the identity of sine squared theta plus cosine squared theta equal to 1. Are you not using this identity? So what do you do with sine squared theta? Sine squared theta, you're going to change it to 1 minus cosine squared theta. This is what you do. Okay, one more time. How do you know you need to do this? One more time. How do you know you need to do this? I know because I go from the right to the left. Instead of me going all the way to your place, we meet somewhere in between. I'm trying to move from the left to the right, but I get stuck. Let's say I get stuck here. I purposely get myself stuck here because I don't know how to continue. Then I will try to move from the right to the left, which is cotangent. I know my cotangent is cosine over sine. This one you should know, right? In the beginning of the lesson, I already told you. So am I one step closer? If you're able to get this, then the next step we're going to write cotangent theta, isn't it? Then I go back one step. Okay, do you know what I'm talking about? I'm telling you the logic why I'm doing this way. If I happen to get stuck from the, I'm supposed to prove from the left to the right, correct or not? But I prove to here and get stuck. So what do? I go from the right to the left. I get cotangent theta equal to cosine over sine. Then I know if I'm able to get cosine over sine, that means the next step is cotangent theta. Then I get the answer already. Yes or no? I move a step closer. In Chinese, what do they say? 退一步，海阔天空 right? 忍一时风平浪静 Okay, so 你退一步 okay, you move one step back. You move one step back is cosine theta over sine theta. Yes or no? Correct. So you compare this one with what you have already gotten. You know in your mind that I'm going to cancel this. If I'm going to cancel that, then I get my answer. Yes or no? So that's why I'm going to tell you I'm going to need this. I'm going to need this. Correct. I'm going to change my sine squared theta to become 1 minus cosine squared theta. Then I have a chance to cancel this. Yes or no? Correct. So what do I get? I get 1 minus cosine squared theta. Don't forget, this is only for sine theta. Here, that I get this, right? Then I minus 1. Yes? And then I plus cosine theta. Okay, are you following up to here? Then this one can cancel, right? No? Yes or no? So 1 minus cosine theta, and then sine theta still there, right? Then after that, I see cosine square, I see cosine, what do I do? Factorize lah. Correct. Don't you think that you need to factorize out the cosine? and then you get 1 minus cosine theta. Yes or no? Yes or no? And then you get the sine theta here. Now you can cancel 1 minus cosine theta. Cancel it off, and then you get the answer already. This is what cosine over sine, and that's why you get tangent theta. Now, I know I may sound a little bit confusing, but I'm running through my train of thoughts so that you can follow what I'm thinking in the exam. That is how you try to figure out, okay, why you want to do maths? Why you want to study so hard for maths? It helps you to figure things out. And one of the best things about maths is you don't have to study so hard. You just know how to figure things out. Of course, the basic you need to know. As long as you know some basic, unlike other subjects, you really have to mark, you really have to remember a lot more things. But for mathematics, you don't need to remember so many things, because you can figure out. As long as you know some basic, correct? Some basic you ought to know, definitely. If not, you got nowhere to start. One more time. See the whole logic, please see the whole logic. Now, let me repeat. If you still have problem, let me repeat this. Now, how do I prove this whole thing? Now, you pay attention now. One more time. You pay attention. How do I get the answer? I clear all this. All right. So first thing you're supposed to prove, and you know you need to start from the left to the right. Okay, but it is not necessary you're able to go all the way from the left to the right. What I'm trying to say is you go from the left to the right, maybe you miss out a few steps before you can get your cotangent theta, which is your right hand side, right? You're supposed to prove your left hand side equal to right hand side. So if I do have any problem, I put a dot here. I have some missing step. I don't know how to get. I get stuck. I go backward. That means I know what to do with the right hand side, right? Can you see cotangent? Now cotangent, don't you think is so obvious that you're going to get cosine over sine? Yes or no? This one you no need to think. This one I already told you, right? You must know. You must know tangent is sine over cosine. You must know cotangent is cosine over sine. That's it. You just move one step back. And then since you continue with this, how you continue from here? What did I tell you? When you see fraction, you always have to combine them, right? Without fail. Yes or no? When you see fraction, you must combine what? You must take common denominator to combine, right? So when you combine, what you get? When you combine, you get this. Now, if you don't know how to get this, you better tell me. Yes, you shouldn't. Okay, you should know how to take common denominator. By now, you still cannot take common denominator. Something is wrong. Okay, so that's how you take common denominator. By the way, you multiply what you don't have. You got sine here. What you don't have? You don't have 1 minus cosine. That's why you get this. Then you multiply 1 minus cosine. This is the last time I'm going to tell you how to take common denominator. I'm not going to repeat this. Okay. Now, you already gotten 1 minus cosine. So what you don't have? What you don't have is sine. Okay, this is the last time I'm going to tell you how to take common denominator. I'm not going to ask you again how to take common denominator. You better know. Now, that is how you get sine square theta minus bracket 1 minus cosine theta. Yes or no? And then what you get? You will get sine square theta minus 1 plus cosine theta over 1 minus cosine theta. Pay attention here. I'm getting the answer already. Now, what did I tell you? I get stuck. Let's say now I get stuck. Usually you will get stuck. Usually you will get stuck here. Let's say you get stuck here. Then you look at your right hand side. I want to meet you halfway. I don't want to go to your house. I want you to meet you at Bishan. Okay, so you come from your house to Bishan. I know it takes a long time. Sometimes you get stuck waiting for bus. Okay, anyway, you go from tangent cosine over sine. Yeah, that's one step back. And you know, once you gotten cosine over sine, you know the answer already because the next step is cotangent theta, right? The next step is what you wanted. But you want to get this right, you just move one step back. As long as you get cosine over sine, you are done. Because the next step is your answer already. So far you know. So you compare cosine over sine. How are you going to get cosine over sine? You tell me. Look at this. Don't you think you can only get cosine over sine if you are able to remove 1 minus cosine here? Yes or no? I make it darker. Don't you think if you're able to remove 1 minus cosine, then your denominator only have cosine, right? Then you got better chance, yes or no? So you ask yourself, how am I going to cancel the 1 minus cosine theta? What did I tell you? The general rule of thumb is to know the most important trigo identity. Here, look at the sine squared. Now, I say again, this is not a new formula. It still belongs to the same identity which I have told you, the most important identity, sine square plus cosine square equal to 1. It's the same identity. It's just that now I see sine square here. Can you see? Now, I will isolate my sine square. I'm going to bring my cosine to the right. So instead of writing sine square, what do I write? I'm going to write 1 minus cosine square. Isn't it okay? This is my sine square theta. That's here. This is my sine square theta. I'm going to change it to 1 minus cosine square theta. Isn't like what I told you? It's the general rule of thumb, right? So after that, what you do? You got minus 1 and then you plus cosine theta. Yes or no? I have already replaced my sine square to become 1 minus cosine square. Of course, the bottom still there, 1 minus cosine theta. And then you have sine theta here. Yeah. Now you can already see I almost get the answer, just 2 steps away. After simplification, what I get? After simplification, I get 1 minus cosine square theta minus 1. I got 1 and minus 1 cancel off, right? Correct or not? And then plus cosine theta. Of course, the bottom one still the same. I'm going to write 1 minus cosine theta and then sine theta. So all I need to do is to factorize out the cosine theta. I factorize out the cosine theta. That's the answer already. Okay, you see how I get? Last step. How do I factorize the cosine theta out? I take out the cosine theta. That's how I take out. When I take out the cosine theta, I get minus cosine theta plus 1. Yes or no? I follow the sequence so that you won't get confused. In fact, I wanted to write 1 minus cosine theta. But following this order, I pull out cosine theta, I will left with minus sine. If I multiply, I should get back this, right now. Because 1 minus 1 cancel off, right? So over here is 1 minus cosine theta. Isn't it the same? These two is the same, right? 1 minus cosine theta, isn't it the same as minus cosine theta plus 1? It's the same, right? Minus 2 plus 1 is the same as 1 minus 2, isn't it? So that's the answer already. So the next step is cotangent. So can you see the whole thing that I've been telling you, how to approach the question and how to do them? So in short, what must you think? What must you think? In short, you must look whether, first step, you must decide whether you want to go from the left to the right or right to the left. Okay, it's easy for you to go from the left to right in this case. Can you see? You know what? You know the next step. When you're given two fractions, what you do? You take common denominator. You take common denominator until you get stuck. Don't worry. You move one step back from the right-hand side. Then you notice, hey, my denominator, I want sine. I don't want 1 minus cosine. I don't want that, you know. So how am I going to cancel it? You remember what I told you? Since you have changed, since you have everything in sine and cosine, then look at the one and only one identity, which is sine square plus cosine square equal to 1. This is the only one I ask you to remember. So when you see sine squared, you just move this to the right. It's the same identity. I repeated that many times. So you just replace that and the rest is history already. After simplification, when you see cosine square and cosine square and cosine, you don't tell me you don't know how to factorize. Isn't it the same like what I told you? When you see minus x squared plus x, you don't know how to take out x. Isn't it minus x plus 1? Minus x plus 1 is the same as 1 minus x, right? Isn't it? Isn't it the same as this one? Then I cancel this one. It's the same like what I did for trigo. It's the same thing. Okay, that's all. That's what I wanted to say. Now, that is how you approach the question. Now, at the end of the day, am I not correct to tell you, you change everything to sine and cosine? On the right-hand side, you see cotangent, you change to cosine over sine. So everything is already in sine and cosine. Then you just use one formula, only one formula. Sine squared plus cosine squared equal to 1. That's it. Okay, I know it's 9 o'clock already. I see very, very quickly. If you don't have question, I do one more. To remind you, I just list down the step like what I do here and repeat the tips I've been giving you. Now, don't worry. Okay, maybe I just do this. Take a look at this. Now, a lot of students, they are very worried about hands. I tell you, I love hands. Okay, can you write down your notes? If you think you can remember, then you no need to write down. But please, I still think that you should write down. When you see hands, can you replace these hands with replace? Okay, can you replace this word hands with this word called replace? So whenever you see hand, you're actually doing replacement or you do substitution. Look at this, what you get from the first part. You're getting this, right? Then replace this whole thing with cotangent theta lah, that's all. What's so difficult? You tell me why it's so difficult about your hands. What's so difficult about your hands? So what did I tell you again? Whenever you see hands, you see what you have proven on top and just replace what you see on the right side. You are replacing, you see this, right? This isn't it the same as this one. So instead of writing this, you write what you see on the right hand side because it's equal to cotangent. So instead of writing this, you write cotangent. Then the rest is just copy. And then you just solve from here. Now, what did I tell you? You want to solve from here? What did I tell you? Cosine over sine, right? Yes or no? When you do tangent, what you do? Sine over cosine, right? Yes or no? Isn't it the same rule of thumb I'm telling you? Then after that, cross multiply. Yes or no? Then you get 3 sine squared equal to cosine squared. Yes or no? Then what did I tell you? You have only one and only one trigo formula. Sine squared plus cosine squared equal to 1. Yeah? So you cannot have two trigo formula here. Or you can reduce to 1 by dividing both sides with cosine theta. Then you solve the problem already, isn't it? Correct. You divide this by cosine theta, you divide this by cosine theta. Why? Because you want to change to tangent. So please write down this note again. Whenever you want to solve trigo identity, write this down, please. Write it down on your notes. Reduce to one type of trigo function. Okay, please write down. Okay, I'm not going to do the next one. Please write this down. It's more important than doing the next one. Okay, what did I say? Whenever you want to solve trigo identity, you cannot have sine, cosine, tangent. You cannot have three identities here. You cannot have three functions. Can you see the three functions? Here. You have sine function, you have cosine function, you have tangent function. You cannot solve. You must change to only one type of trigo identity. So that's the idea you must have, no matter how. That's also the reason why you always use sine squared plus cosine squared equal to 1. Because you're going to replace cosine squared with sine squared, or you're going to replace sine squared with cosine squared. You will eventually reduce it to only one type of trigo function. Understand? Now, since I have divided cosine squared on both sides, then I have reduced sine and cosine to become tangent. Then only one type of trigo function. That's what I mean. So I have given you very good tips. Please use them. Please use them when you solve questions. That's why I want you to write down. Along the way, every lesson, I'm going to continue telling you the tips that you need to use, and please use them. Then you tell me whether they are useful or not. Cannot. So please, you put what you have learned into practice. Now, I can be a very good coach. If you don't follow my instruction, you can do your own way and then you get stuck. And what can I say? Right? If you play table tennis, you listen to your coach. The coach say you want to do this thing, you must at least follow what he say and see whether it works for you or not. Correct. If you still do your own way, then it's difficult for you to improve, right? So the same thing. Anything you learn, in fact, anything you learn, you try to follow instruction first. Then of course, when you're expert already, then you can do your own way. You say, oh, I can improvise a bit. Maybe I can do better. Then by all means. But these are the basic, this basic, 基本功, these are the basic. You just follow. Okay, so that's it. Now, what is the other way? Last one. So instead of writing cosine, can I write 1 minus sine square? I can also do like that. Can you see now? So what have I done? I have reduced to one type of trigo function, which is sine, right? Then I solve trigo, I solve quadratic equation. I can also get answer. Same thing. Can I see it like that? You understand now? So this is a quadratic equation. I can also do like that. I can also get my sine theta. Instead of changing it to tangent, I change everything to sine. How do I change everything to sine? I use the only one and only one identity. Sine square plus cosine square equal to 1. Then cosine square is 1 minus sine square. Then I have successfully, oh no, sorry, it's square, right? So if it is squared, even easier, right? So it becomes sine only lah. I think I made a mistake here, going too fast. So 1 minus sine square, I move over, I get 4 sine square, right? Beg your pardon. So here, okay, then luckily I find this. Okay, 4 sine square, I move this over to the left. 4 sine square equal to 1. Then I get sine square theta equal to 1/4. Then I get sine theta equal to plus minus half. Okay, so you get sine theta equal to half or sine theta equal to minus half. That's it. Then you solve from here, ASTC. Cannot. So you can still get the angle, whether you want to reduce to sine function, because you have changed the cosine to become sine. So you only left with one type of trigo function, isn't it? Correct. Either you have left with either one type of trigo function, which is sine, or you can divide cosine square and change it to tangent. You also have one type. So tangent square is what? Equal to 1/3. Correct. So tangent is square root lah. Tangent theta equal to plus minus square root 1/3. And then you solve from there, ASTC. Okay? All right. Okay, since we have started from 7:30, so now it's already 9:07. Okay, got any question? Or you can stay back. I mean, if you don't understand, you can stay back. I'm still here. Okay, I hope you learned something from today's lesson. And I hope you have written down the tips I've given to you. Please change everything to sine and cosine and use this sine squared plus cosine squared equal to 1. And then you know how to prove identity. And you must try them. You really have to try them. I've sent you quite a few questions during the break. And then just do them. These are from your 10-year series. But if you have problem, let me know. Can always send me the WhatsApp in between the week. I also send you a few more questions for homework. Please do them. If you do them, then I know what you don't know, right? I mean, another week is gone, Then I also don't know what you know or you don't know, right? So next week, I may repeat something you already know. So no point, then you waste time. Okay? Any question? Hello? Any question?
No.
Can If no question, you can log out now. If you have some more question, you can stay back. I'm still here. Okay, Zhao Ling. Okay, Zhao Ling. How do you feel, Zhao Ling? Okay, now am I still going too fast?
Just sometimes I need to
Yes.
it's a bit I cannot keep up. So, but just sometimes.
Okay. So don't worry, don't be shy. You can be like this because the rest log out already. You are the only one here. So give me more feedback and tell me how you feel about the lesson and which part is too fast. Proving identity, do you get it? Do you know how to prove?
Yeah, I think so. But it's like that time when you're talking about the formulas and stuff like that, I think.
Oh, okay. So you're talking about the angle sum like cosine A plus B, sine A plus B, isn't it? You're talking about that, right?
Sound and the formulas.
Okay, okay. Now you don't mind, ah? Can you stay back for 5 minutes?
Okay.
Okay, you see, ah? Now you can see on the screen here.
Yeah.
Okay, let me open up. I want to share the screen. Okay, you can see the whiteboard here, right? Can you see the screen I'm sharing? Can you see the whiteboard? Can you see the whiteboard I'm sharing? Cannot wait. Wait, let me try again.
And
Can see not? Okay, maybe I just